Yeah, everybody turn in your problem sets, and I'm going to get started. There, you turn them in up front here. So today we're going to consider the firm's supply decision, and that will have two parts to it. So first we'll talk about the way that you turn a marginal cost curve into a supply curve. And that'll involve talking a little bit about a firm's shutdown decision and how you generate a supply curve and how it's only the area above the average cost curve. We'll then talk about producer surplus and profits and different ways to represent these graphically. Then we'll turn, and all that stuff's going to be pretty by the book. It's pretty straight out of Varian. Then we're going to turn to what I think is sort of somewhat more interesting topic, which is the issue of the duration of supply and how we interpret time in the context of supply models. And to do that, we'll talk about durable and storable commodities, which you're supposed to read about, and then use Le Chatelier's principle to link those to issues of the short and the long run. And then in the context of durable commodities, we'll talk about supply over various runs and the relationship among different supply curves, and then relate that to what I call Marshallian dynamics, which is how you can use static models to think about what happens in markets over time. OK. So for the next couple of weeks, firms are going to be price takers. And that's going to mean that a firm basically is small enough in a market so that when it changes its quantities, the prices that it faced change by such a small amount that it doesn't really matter. And we're going to give foundations for this in Lecture 16 towards the end of the course. So for a firm that takes prices as given, the price is just fixed, and the firm is going to maximize the price that it gets times the quantity it produces minus the total cost as a function of the quantity. So what is going to be its first order condition? Somebody who wants to. Sorry, what's your name?
Jackson?
Jackson. Yeah, Jackson.
They would produce until the marginal cost was equal to their price.
Exactly. Because the derivative of the first term is just price. The derivative of the second term is the marginal cost, right? OK. So price equals marginal cost. Another way to put that is that quantity is equal to the supply function, where that's defined as the inverse of the marginal cost curve. So let's return to the example Cobb-Douglas from before. Let's imagine that the marginal cost curve, and as you guys found out, Cobb-Douglas is the same in its cost function as a general homogeneous production function. So the homogeneous production functions have marginal cost curves of the form k times output to the alpha, where alpha is some either positive or negative number. And that's how we're supposed to try to match those various functions, right? If this is not increasing, there's going to be a problem that we'll talk about in a moment. But let's assume for the moment that we weren't in one of those ones where it's decreasing. We were in one where it's increasing. So alpha is greater than 0. Then what is going to be the supply function here? Who wants to remind me of your name? K. Yeah.
So it should be like the alpha root of P over K.
Yeah, that's exactly right. Absolutely. OK. So I think this screen is getting cut off a little bit, so let me put it down a little bit. OK, so this is the fundamental supply equation. The marginal cost curve is typically going to be basically the same as the supply curve, except as Kay was pointing out, you have to invert the marginal cost curve to get the supply curve. However, there's two problems that can arise. So first of all, firms are not going to produce unless they make enough profit, right? So if they're actually making losses, they're not going to produce at all. And that says that they'll never produce at a price that lies, a price-quantity pair that lies below their average cost curve. So it's only going to be the part of the marginal cost curve that's above the average cost curve that corresponds to the supply. So for example, many airlines will stop running a particular route if they're not getting enough passengers going on that route, because the fixed cost of running that particular route exceeds the costs that they get from each passenger, the profits they make off each passenger. The other possibility is the marginal cost could intersect price at many different points. And then the firm has to choose the most profitable point. So one feature of the most profitable point is it will always be a point where the marginal cost cuts from below to being above the price, because otherwise it's going to be a local minimum of your profits. But there may be many such points, and to choose all of them, you need to, between all of them, you need to choose the one where you get the greatest area between the two. So I'll show you what I mean by that in just a second. Okay, so, well actually, why don't I just show you here? So if we have fixed costs, the average cost curve might look like this. The marginal cost might look like this. The firm, if the price is here, is never going to produce there. They'll only start producing here. So the supply curve is really the area above this intersection, right? It sort of goes to 0 here. Another example is, here's a case where there's 3 intersections actually, right? The average cost, the marginal cost, imagine that price were to cut through here, right? I guess this was set up for a time when I used to be able to draw on this. Maybe there's a ruler that I can use. Imagine that price cut through here, right? Then there would actually be 3 intersections of price with the marginal cost curve. Now the question is, which of these corresponds to the actual quantity that the firm will produce? Imagine that the price is here. Can anyone tell me what each one of these 3 intersections corresponds to? Yeah, Joe.
The marginal cost equals price, the marginal revenue.
This is marginal cost equals price here. Which one is the firm going to produce at, and what do the 2 other intersections correspond to?
Well, it produced the one at the far right.
Would it?
No, the far left.
I'm in the middle.
No, the middle one, that just had a marginal cost.
Okay.
The middle one is where it intersects from below to above.
No, but it's from above, below to, no, from above to below is in the middle one. So that one's a local minimum. So it definitely is never going to produce at the middle one. Now, does someone want to advocate for the one on the right? No. Joe, you said that. Why is it the one on the right?
Well, I'd like to change my answer.
Okay.
Because of that, there's the area above the line. From the first to the third point, the area above is where you're losing money.
Exactly.
In that
area below is where you're making money. And so that, now imagine I raise it up to here. Now where are they going to produce? Far right. Well, okay, so this sort of previews something we'll do a little bit later in the class, but there's something called an ironing line. An ironing line is the line that we could draw so that there's equal area above and below. And one thing we could do with this marginal cost curve is we could just chop off the area above that line and chop off the area below that line, and we could just treat the marginal cost curve as if it was this ironed out thing. And that would be equivalent to the original marginal cost curve for the purposes of supply. And that's the thing that I was saying about firms acting effectively if they have, as if they have decreasing returns. Because the other areas you'll never observe in the behavior of the firm, because those get sort of cut off effectively, right? They don't end up mattering. And in fact, you can view this whole shutdown decision in the same terms, because you can imagine that actually there's like some really, really high marginal cost of producing the first unit, and then it falls down to this, and then it starts coming up again. And so really what you're doing when you choose this point is you're ironing those 2 things out, and you're making it just be equal to that there. So that's really sort of the principle behind this, is you cancel out the areas where it's sort of declining with areas where it's increasing, and you make it into something that's increasing, and that gives you the real supply curve. Okay. So this is the sense in which there's never really a competitive firm that has increasing returns. Because either you can iron things out, and by the time you get to it, they effectively act as if they have decreasing returns, or they're going to just produce a ton of stuff, right? In which case, they're no longer going to be competitive, because they're going to be a big part of the market. So this is why we say that there's never Giffen goods in supply, or that the firm supply is always upward sloping. Because either the firm is not going to be competitive, or they're whatever bumps are in the supply curve are going to get ironed out, and eventually you're going to get one of these increasing supply functions. Okay. Now, producer surplus that a firm earns is just the price times the quantity minus their total cost. Another way of putting this is it's price minus average cost times quantity, right? That's just equivalent to the first. Another way of putting it is that it's the area between price and marginal cost. That was what we were just doing, right? You were saying that all the area above the price and below the marginal cost is losses, and all the area below the price and above the marginal cost is gains. And so you can sort of shade that whole area. There's another way that we can do this, which is, let me just draw this out. So imagine I have a marginal cost curve like that. That's the price. So we know this area is producer surplus. Another way of putting that is that we can integrate along here. Well, okay. Let's see. Okay, so probably the right way to look at this is to say we could also add up along the price axis slices that are like this, right? So that's the integral of price going from 0 to the level of price of the quantity that the firm would produce at that price, right? The way to think about that is that as the price rises, how much does the firm gain? Well, it gains however much it's producing at that price, right? And so that also tells you the profit that the firm makes. Another way of thinking about that is that if we want to do the same adding up this way, we can, rather than integrating along price, we can integrate along quantity, but then do a change of variables where at every point we're doing things proportional to the slope of the marginal cost curve at that point, right? Because if the marginal cost curve were really flat as we go along, there's basically like no vertical space covered as we go along the quantities. Whereas if the marginal cost curve is really steep, we cover a lot of vertical space for every quantity. So if we make this proportional to the slope of the marginal cost curve, that's another way of adding things up. And one thing that that tells you is that profits are going to be proportional both to how much you produce, but also how inelastic your supply curve is. If it's very inelastic, then you'll have a lot of profits. If it's very elastic, you'll have less profits. And the more that it's inelastic at parts where there's a high quantity already, the more profits you're going to make. Okay. So that is basically the basics of supply. You know, the reason I went through that so quickly is you can read about it in Variant. It's sort of, I think, a little bit boring. So